So today we start with the next sequence of 10 best questions in the chapter of vectors. So here we start with the first one. The question goes like this. If with reference to the right-handed system of mutually perpendicular unit vectors I, j and k, vector alpha is given as 3i cap minus j cap, vector beta is given as 2i cap plus j cap minus 3k cap. You are being asked to express vector beta, means this vector, in the form beta vector is equal to beta 1 vector plus beta 2 vector, where the first vector beta 1 that you can see is parallel to alpha vector, this given vector, and the second vector beta 2 here should be perpendicular to alpha. This is a basic requirement. So the very first thing to understand here is that when they say right-handed system of mutually perpendicular unit vectors I, j and k, they are basically the unit vectors determining the directions of positive x-axis, positive y-axis and positive z-axis respectively. So you're being asked to express this vector beta in the format beta 1 plus beta 2. Let us talk about beta 1. What is given about beta 1? What is specific about beta 1? Beta 1 here is given parallel to alpha. We utilize this information since beta 1 is parallel to vector alpha. When we have two vectors which are parallel, so one of them can be written as some scalar or a constant times of other one. So therefore we will prefer writing vector beta 1 is equal to some lambda, some constant lambda or scalar lambda times of alpha. What is alpha vector here? It is 3i cap minus of j cap. This is given. We can open it further. Let us open it. We have 3 lambda I minus of lambda j. So this is what we can write for beta 1. Something about beta 2. Beta 2 should be perpendicular to alpha. Now you just observe they're asking us to express beta as the sum of beta 1 and beta 2. Beta is already given to you, means this is known to you. Beta 1 you have written just now. Beta 2 can be written as beta minus beta 1. So from here, if I prefer writing beta 2 vector, I can write it as vector beta minus vector beta 1. Vector beta is already given as 2i cap plus of j cap minus of 3k cap. This is vector beta. From there, I have to subtract beta 1. I have to subtract beta 1. That means just need to change the signs of the terms attached with I and j. So I'll be writing minus of 3 lambda I cap and plus of lambda j cap. Now after that we will gather the terms containing I and j. You can observe we have I here and with 2 means we have 2 twice of I and we have minus 3 lambda I. So if I club the terms containing I, what I can write is 2 from here minus 3 lambda from here and I can be picked as common I cap, right? Likewise, we have the term of j cap appearing twice here. We do the same thing here. So with j we have 1 and with j here we have lambda and they are in addition. So we have 1 plus lambda attached with j cap. We have only minus of 3k cap. We don't have other k cap available. So this is the final expression for vector beta 2. Now what is specific about beta 2? We haven't utilized this portion anywhere. So when they have mentioned beta 2 is perpendicular to alpha, we know that if two vectors they are mutually perpendicular, means they are perpendicular to each other, then their scalar or dot product will vanish or it will come out as 0. So what we will utilize from here is that vector beta 2, its dot product with vector alpha must be equal to 0. If we utilize this information for beta 2, I have the ready vector 2 minus 3 lambda of I cap plus 1 plus lambda of j cap minus of 3k cap. I keep it in a bracket. This is beta 2. Its dot product with alpha vector. Alpha vector is already defined as 3i cap minus of j cap. There is no term of k cap, so for clarity of thought, I can write 0 k cap, and we have the other side as 0, so I can write 0 here also. While performing dot product, we know that the scalar components of I get multiplied together. So scalar multiple of I means the term or the expression or the scalar attached with I. It is 2 minus 3 lambda from here. From the other bracket, the I component, or you can say the scalar component, is 3 here. So it is 2 minus 3 lambda in product with 3. So I can write 3 times 2 minus 3 lambda here. Likewise, with j, I have 1 plus lambda, and with j, we have minus 1. So the j components will also get multiplied. We can write minus 1 from here, and in product with 1 plus of lambda here. Likewise, the k components will also get multiplied. K component here is 0. So 0 multiplied by minus 3 makes it 0. So no need to write that. But on the other side is already 0. We can simplify this portion further. Let us see what happens. We can write 3 2s are 6 over here, minus of 9 lambda over here, minus of 1 and minus of lambda, and on the other side it is 0. We can observe we have lambda appearing twice. We have minus 9 lambda, minus of lambda, that makes it minus 10 lambda. If I shift it to the other side, what we get from here is 10 lambda, and on the left hand side we have 6 minus 1, that makes it 5. So if I further simplify to get the value of lambda from here, I get 5 by 10 or 1 upon 2. So this is the value of lambda that we have obtained here. Now they are asking us to express this vector beta as a sum of beta 1 and beta 2. That means the basic idea is to find vector beta 1 as well as vector beta 2. So vector beta 1 has lambda involved in it, and we have just solved for lambda. So this lambda is equal to half can be substituted here. So the final expression for beta 1 comes out as 3 into half here. So it becomes 3 by 2 I cap minus of again lambda, it is half of j cap. This is beta 1, and we have the expression for beta 2 here. So we can write lambda as 1 upon 2 here also. So for beta 2 vector, we can write 2 minus 3 upon 2 of I cap plus 1 plus, again lambda is half, 1 upon 2 of j cap minus of 3 cap. This last term is without lambda. We can simplify this portion further. We can write 1 upon 2 of I cap plus 3 upon 2 of j cap minus of 3k cap. This is the final expression for vector beta 2. Now just in the final step, just need to write beta as sum of beta 1 and beta 2. So you can observe, we have beta given to us. We have obtained beta 1, we have obtained beta 2. The final step involves writing this beta vector, which is 2i cap plus j cap minus of 3k cap. It can be written as sum of beta 1, which is 3 upon 2i cap minus of half j cap, and beta 2, which is half of I cap plus 3 upon 2 of j cap minus of 3k cap. A final check to verify if you have arrived at the correct answer or not is to combine the right hand side, and it should match with the left hand side. Of course, we have written this as sum of two vectors, but for your clarity, 3 by 2 I and 1 upon 2 I. 3 by 2 plus 1 upon 2 makes it 4 by 2, that makes it 2. So twice of iota, which is the left hand side here. Then we have minus of half j and plus of 3 by 2j. So 3 upon 2 minus 1 upon 2, that makes it 2 by 2, which is simply 1. So 1 of j, which is here. And final term minus 3k is already there. It's a free term existing here. So this way, we have expressed vector beta as sum of beta 1 and beta 2, where beta 1 is parallel to alpha and beta 2 is perpendicular to alpha. It is one of the most important sums, and you should do it in written on your own. No doubt I have explained it here. I have given the complete solution live, but remember, unless until you do it by your own hand, on your own, it's all waste. So you should take care that whatever I'm teaching here, you should be doing it in written. Then only it is going to be beneficial. Take care, and then we start with the second question now. Thank you.